Eigenvalue and Eigenvector for symmetric matrix. So definition of symmetric matrix: a square matrix A is said to be symmetric if A equal to A transpose. First row and first columns are equal. So here 6 minus 2 2, 6 minus 2 2. Second row and second column are equal. Similarly third row and third column are equal. Therefore the given matrix is symmetric matrix. So question is, find the eigenvalue and eigenvector for the symmetric matrix A equal to 6 minus 2 2 minus 2 3 minus 1 2 minus 1 3. So step number 1, to find characteristic equation. So we know that characteristic equation for 3 by 3 matrix is lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0, where s1 is sum of the main diagonal elements. Here diagonal elements 6 3 3. So 6 plus 3 plus 3, which is equal to 12. S2 is sum of the minor of the main diagonal elements. So minor of 6 is 3 minus 1 minus 1 3. Then minor of 3 is 6 2 2 3. Then minor of 3 is 6 minus 2 minus 2 3. So which is equal to 3 into 3 9, 9 minus 1 8. So 6 into 3 18 minus 2 into 2 4. 6 into 3 18 minus 2 into minus 2 plus 4. So 9 minus 1 8, 18 minus 4 14, 14. So 28 36. S3, determinant of A. So determinant of A is 6 minus 2 2 minus 2 3 minus 1 2 minus 1 3. So determinant expansion 6 into 3 3s are 9 minus 1 into minus 1 plus 1. So plus 2, here minus 2, so I am writing here plus 2, minus of A to 2. So minus 2 into 3 minus 6 minus 2 into minus 2 into 3 minus 6 minus 2 into minus 1 minus 2, so plus 2. Plus 2 into minus 1 into minus 2 plus 2 minus 2 into 3 6. So 6 into 9 minus 1 is 8, minus 6 plus 2 is minus 4, 2 minus 6 is minus 4, so which is equal to 48 minus 8 minus 8. So how much? 32. So therefore the characteristic equation is, substitute the value of S1, S2 and S3 in equation. So therefore lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0, which is the required characteristic equation for given 3 by 3 matrix. Then step 2, to find eigenvalues. So to solve the characteristic equation, we get the characteristic roots or eigenvalues. So by synthetic division, write on the coefficients of lambda cube 1, lambda square coefficient minus 12, lambda coefficient 36, constant is 32. So here we want 0, here 1. So by trial and error method, start with plus 1, minus 1, plus 2, minus 2 and so on. If you put lambda equal to 2, so what is 1 into 2? 2 minus 12 plus 2 is minus 10. So minus 10 into 2 is minus 20. So plus 16, 2 into 16 is 32 0. Again one more time. Since it is a cubic equation, we have to get 3 roots. So again I am trying to. So 1 into 2 is 2, minus 8. Minus 8 into 2 is minus 16. Therefore the eigenvalues are, what are the values? 2, 2. Here lambda minus 8, the constant, this coefficient of lambda minus 8 equal to 0. So lambda equal to 8. therefore write it in opposite sign. A minus 8, I am writing a plus 8. Here 2 repeated twice, therefore it is repeated eigenvalue for symmetric matrix. Step number 3, to find eigenvectors. Step number 3, to find eigenvectors. So we know that eigenvector equation is a minus lambda I into x equal to 0. Where A is the given matrix, lambda is the eigenvalue, I is the unit matrix, x is the non-zero column vector. Therefore, we get 6 minus lambda minus 2, 2 minus 2, 3 minus lambda minus 1, 2 minus 1, 3 minus lambda into x1, x2, x3 equal to 0. So first case 1, when lambda equal to 8, first we do for non-repeated. Roots are 2 to 8, first we do for 8, non-repeated eigenvalue. So put lambda equal to 8, we get 6 minus 8 is minus 2, minus 2, 2, minus 2, 3 minus 8 is minus 5, minus 1, 2, minus 1, 3 minus 8 is minus 5 into x1, x2, x3 equal to 0. So just multiply, we get 3 equations. So first equation is minus 2x1 minus 2x2 plus 2x3 equal to 0. Second equation, minus 2x1 minus 5x2 minus x3 equal to 0. Third equation, 2x1 minus x2 minus 5x3 equal to 0. So all the 3 equations are different. So all the 3 equations are different. So consider any 2 and solve by cross multiplication rule. All the 3 equations are different. So consider equation 1 and 2 and solve by cross multiplication rule. And solve by cross multiplication rule. What is equation 1? In equation 1, throughout divided by minus 2, we get x1 plus x2 minus x3 equal to 0. In equation 2, throughout divided by minus, we get 2x1 plus 5x2 plus x3 equal to 0. So apply cross multiplication rule. Start with x2, end with x2. So what are the coefficients? x2 coefficient 1, x3 coefficient minus 1, x1 coefficient 1, x2 coefficient 1. In equation 2, x2 coefficient 5, x3 coefficient 1, x1 coefficient 2, 5. So just apply determinant expansion. 1 into 1 is 1 minus 5 into minus 1 is minus 5, so plus 5. x2 minus 1 into 2 minus 2 minus 1 into 1 is 1. x3 1 into 5, 5 minus 2 into 1 is 2. So therefore x1 value is 6, x2 value is minus 3, x3 value is 3. So throw divided by 3, we get 2 minus 1, 1. So therefore first eigenvector is 2 minus 1. Then case 2, when lambda equal to 2. Case 2, when lambda equal to 2. So put lambda equal to 2, we get 6 minus 2 is 4, minus 2, 2, minus 2, 3 minus 2 is 1, minus 1, 2 minus 1, 3 minus 2 is 1, into x1, x2, x3 equal to 0. So just multiply We get 4x1 minus 2x2 plus 2x3 equal to 0. Second equation, minus 2x1 plus x2 minus x3 equal to 0. Third equation, 2x1 minus x2 plus x3 equal to 0. So let it be equation 1, 2, 3. So equation 1 through divided by 2, we get 2x1 plus x2 plus x3. In equation through divided by minus, we get 2x1 minus x2 plus x3. Right? 2x1 minus x2 plus x3. All the three equations are same. All the three equations are same. All the three equations are same. So therefore, consider the equation 2x1 minus x2 plus x3 equal to 0. So put any one of the variable, find out the second eigenvector. So I am substituting here, put x1 equal to 0. So if you substitute x1 equal to 0, we get minus x2 plus x3 equal to 0. So minus x1, x2 equal to minus x3. So therefore, x2 value 1, x3 value 1. Therefore, second eigenvector is 0. x1 value 0, x2 value 1, x3 value 1. Right? First eigenvector is 2, minus 1, 1. Second eigenvector is 0, 1, 1. Case 3. Here 2 repeated twice, right? Repeated eigenvalue. So, by the property of symmetrics, eigenvectors are pairwise orthogonal to each other. Eigenvectors are pairwise orthogonal to each other. Eigenvectors are pairwise orthogonal to each other. That is, in notation, x1 transpose x2 equal to x2 transpose x3 equal to x3 transpose x1 equal to 0. So all the three eigenvectors are pairwise orthogonal to each other. So let's consider the third eigenvector. Let x3 equal to x1, x2, x3 be the third eigenvector, which is orthogonal to x1 and x2. Right? All the three eigenvectors are pairwise orthogonal to each other. Therefore, x1 is perpendicular to x2, x2 is perpendicular to x3, x3 is perpendicular to x1. So therefore, x3 perpendicular to x1 implies, perpendicular means A is perpendicular to B, meaning is A dot B equal to 0. Similarly, x3 is perpendicular to x1. What is x1 eigenvector? 2 minus 1, 1, right? So x3 is x1, x2, x3 perpendicular to x1. What is x1? 2 minus 1, 1. So A is perpendicular to B, A dot B equal to 0. That is the meaning 2x1 minus x2 plus x3 equal to 0. Let it be equation. Right? Just multiply 2 into x1 minus x2 plus x3 equal to 0. Similarly, x3 is perpendicular to x2 implies, what is second eigenvector? 0, 1, 1, right? So x1, x2, x3 is perpendicular to 0, 1, 1. So just multiply A dot B equal to 0. So 0x1 plus x2 plus x3 equal to 0. Let it be equation 2. So solve 1 and 2 by cross multiplication rule. So start with x2, end with x2. So in equation 1, what is x2 coefficient minus 1, x3 coefficient 1, x1 coefficient 2, x2 coefficient minus 1. In equation 2, x2 coefficient 1, x3 coefficient 1, x1 0, x2 1. So therefore, what is x1 value? Minus 1 into 1 is minus 1 minus 1 into 1, 1. x2 value 1 into 0, 0 minus 1 into 2, 2. x3 value 2 into 1, 2 minus 0 into minus 1, 0. Therefore, minus 2 minus 2, 2. So throughout divided by minus 2, we get 1, 1, minus 2. This is the third eigenvector. That's all.